Every time a user clicks a button or requests a page, an electrical signal begins a journey. It leaves the local device, traversing the void of the internet, searching for a specific destination server where it can execute its command. But allowing raw, unfiltered data to travel freely between a client and a core system is a liability. Malicious payloads, malformed requests, or simply too much traffic can easily compromise a vulnerable server. This creates an architectural problem. Developers need a way to stop unauthorized access, log system events, and delay heavy processing. But writing those individual checks directly into the core application logic for every single interaction creates a fragile, tangled mess of code. The solution is a layer of invisible software glue known as middleware. Instead of sitting at the origin or the destination, middleware is positioned perfectly in the middle, acting as a strict gatekeeper for every piece of data trying to pass through.
This interceptor pattern is a powerful structural concept. It scales seamlessly, governing both the massive traffic flows of global enterprise backends and the localized micro-interactions happening inside your browser window. To see this at the macro level, we look at the backend. IBM defines backend middleware as a mediator between modern clients and legacy resources, bridging the gap to massive, older systems like mainframes and traditional databases. Operating in REST, backend middleware intercepts HTTP requests, scanning JSON packets before they reach the server. It enforces security protocols, firmly rejecting requests without valid authentication tokens. It also manages heavy traffic, slowing flooding IPs and organizing requests into metered queues to prevent server collapse. Beyond security and traffic, middleware can actively read a client's HTTP header to dynamically customize responses. An e-commerce application can look at an incoming IP address and instantly route the user's search results to the nearest physical store. On this macro scale, middleware ensures servers only process requests that are vetted, formatted, and throttled, keeping core application logic isolated from raw network traffic. The mechanical secret behind all of these middleware architectures relies on a single universal tool, the next function. The logic flow is strict. When middleware finishes inspecting a request and decides it is safe, it must explicitly call next_to. This command tells the system to pass the data down the chain to the next layer of the application. But if the middleware detects an anomaly and omits the next_to call, the request is instantly killed. The connection drops, and the core application code is entirely shielded from the bad data. This binary choice determines whether a request reaches its destination or is discarded before doing damage. It makes a modular, multi-layered security pipeline possible, and this logic is entirely stack-agnostic. The next function operates the exact same way, whether it's protecting a global enterprise database or updating a simple user interface on your laptop. Zooming in from the global backend server to the local web browser, we see the exact same architecture in frontend state management tools like Redux. Frontend middleware intercepts local user actions, like clicking a submit button, pausing them before updating the screen. This pause allows developers to record actions to a console for debugging. It also manages asynchronous operations, holding actions indefinitely until external API data arrives to update the UI. It even has the power to dynamically alter a payload. Frontend middleware can intercept an action, secretly force a specific variable to change, and send it along, keeping the original action type identical. At this micro level, interception ensures that every state change is predictable. By handling side effects like API calls and logging before UI updates, middleware provides a clear record of how the application reached its current state. Looking at both scales, the symmetry is clear. Backend middleware connects disparate systems and protects servers from the outside world, while front-end middleware ensures state predictability inside the local browser. Before this interceptor pattern became standard, applications were a tangled mess. Developers had to manually weave security checks, logging, and data fetching directly into their core application logic, resulting in fragile code. By extracting those responsibilities into a separate layer, software architecture evolved into a clean, modular pipeline where every piece of data is inspected before it is trusted. The best solutions in computer science aren't tied to a specific programming language or side of the stack. They are structural truths that work everywhere. By mastering the invisible space perfectly between the trigger and the destination, developers gain total control over how their software behaves.